In this demonstration, we're going to discuss how to configure uninterruptible power supplies, or UPSs. Using a UPS is a really good idea, especially for sensitive systems. A UPS maintains AC power and a battery in case of a power outage. This gives you a window of time to bring the system down cleanly. Remember, Windows doesn't like unclean shutdowns. They can corrupt and lose data. Before we talk about how to configure the UPS, we need to identify one key mistake that a lot of users make when they connect a UPS to their system. Many users plug their system's AC cable into a protected outlet on the UPS, but they don't ever connect the management cable. Most UPS systems have a USB cable that you plug into your PC system. This cable allows communications between the UPS and the computer's operating system. Using this cable, the operating system can monitor the battery's charge. In return, the UPS can send commands to the operating system to shut down. For example, if a power outage occurs, the UPS can send a command to the operating system saying, "We need to shut down because my batteries are going to run out in 5 minutes." If you don't connect the management cable, there is a chance that the UPS's battery capacity will be shorter than the duration of a power outage. So, how do we set this system up? First, we plug the UPS system into a wall outlet. When you initially purchase a UPS, the battery will probably need to be charged for quite some time, maybe even overnight, before it reaches 100%. Then I plug my PC into one of the protected outlets on the UPS. Be very careful with this because you'll often find that only some outlets are battery backed and others only provide surge protection. If you plug your PC into a surge only outlet, you don't have any battery backup. Next, we need to plug in the serial or USB cable from the UPS to the PC system and install the UPS management software. I've already done both of those things. As you can see, I have UPS software installed and running on my Windows 10 machine. The actual software you use will depend on which UPS you've purchased. The APC company provides a popular UPS system that uses PowerShoot software, so that's what we're using. When we start the PowerShoot application, by default, the Monitor Your System tab is displayed. Here we can see a summary of historical power events that have occurred, and we can also view battery backup status information. Here we can see that electrical power is currently supplied by the AC utility power. In other words, the system is running on AC power from the wall outlet. Right now, it's not running on battery. The battery is 100% charged. We haven't had a power outage and we haven't had to switch to battery power recently, so no historical battery events are recorded. And here we can see the input voltage coming in from the wall outlet. So, we know that the UPS is functioning properly, we're all hooked up, and everything's ready to handle a power event. Now it's time to make some configuration changes. Let's go down to options. One of the things we can do is enable PowerShoot notification sounds. This is a good idea. A lot of people turn this function off because when the power goes off, it makes a really annoying, noisy sound. But you do have the option to enable notification sounds. This option gives audible notifications that the system is running on battery power. Let's go to the runtime configuration. This is probably one of the most important configuration screens. We have two different options here. We can preserve battery power or just keep the system running as long as possible. There's two different things involved here. This one says basically if a power outage occurs, run on battery until we're down to about 5 minutes left in the battery capacity, then initiate a shutdown. It's set to 5 minutes because sometimes it takes a few minutes for a computer to go all the way down. We want to make sure that there's plenty of time for the shutdown to occur because there's no point in having a UPS if it runs out of battery in the middle of the shutdown process. You're almost guaranteed to end up with corrupted files somewhere in the system if it goes down in the middle of a shutdown process. The other option, the one I prefer, is to preserve battery power. Instead of keeping a system running as long as possible, with this option we're saying, please shut down this computer after it's been on battery backup for a very short amount of time. In this case, it's set to 5 minutes. So, if we have a power event and the power doesn't come back on within 5 minutes, this computer system is going to shut down. I prefer this option because often, such as during a storm, the power will go off and on several times, and my batteries will start to drain. I like to wait until the power event is pretty much over, so my system doesn't go back and forth between battery and normal power. If you use this option, you may not have enough battery power left in the UPS to shut down the system cleanly. If you use this option, on the other hand, you'll still have plenty of battery power to shut the system down cleanly once again. As you can see down here, my estimated battery time is 343 minutes. If I shut my system down 5 minutes after a power event, I can do that many times over and over without experiencing an unclean shutdown. So let's go ahead and apply the change here. Next, let's configure our notifications. Here we can configure our battery backup alarms. The option we configured earlier was the PowerShoot notification sounds, meaning that Windows itself is going to pop up a notification and generate a sound to let us know the system's on battery power. Down here, we're configuring the backup battery unit itself. If you've ever had the power go off and heard the terrible, horrible beeping sound that the UPS makes, you know what this sound is. We have several different options. We can enable the backup battery alarm at all times. We can also disable it. That's probably not the best idea because you want to know if the power has gone off and that your system is now running on backup battery. I don't like this option either because it may kick off in the middle of the night when I really don't care because I'm not doing anything on the PCs. So the default option is one of the better options. Basically, it'll enable the backup battery alarm during the workday. But if the power goes off between 8 p.m. and 8 a.m., we don't care as much. We're asleep. So we're going to let the UPS shut down the operating system cleanly. We'll leave that set to its default value. Let's go down to sensitivity. This is where we specify the circumstances when we want the UPS to kick in. Remember that your UPS not only protects your system from power loss, but also from electrical noise. So if the UPS detects enough electrical noise on the input power coming from the utility company, it can shut that off and use battery power in order to protect your equipment. That's a good thing. We have 3 different levels of sensitivity. Low causes the system to switch to battery power less frequently, but it could, as it notes here, allow greater voltage distortions to reach your computer, which could potentially damage your equipment. Medium is a good setting because it switches the system to battery power when moderate amounts of voltage distortions hit the computer. If you want maximum protection against electrical noise, you can select high. Be warned, however, that almost all utility companies have a certain degree of voltage distortion coming in through the AC power line. Depending on your utility company, the high setting could cause the system to go onto battery constantly. That's why medium is usually selected by default, and my experience has been that medium is just right, so we'll leave it at the default value of medium. Now let's come down here and select voltage. In this screen, we essentially define what a power event is. We specify a high and low voltage threshold. Normal utility voltage is between 115 and 120 volts. If the AC utility voltage goes above 139 volts, we're going to go on battery because we're assuming that some kind of spike is coming down the line and we don't want that. However, if the voltage drops below a certain value, in this case 92 volts, we're going to assume that we're dealing with a brownout of some type. Once again, we want to go on battery. I usually leave these set to the default settings, but you can adjust them. Down here you can see what the current power source is. We're running on AC utility power, and the estimated battery time brings up a really important point. This estimated battery time assumes there is one PC connected to this UPS. Often, people will plug multiple systems into one UPS, and that will drain your batteries faster than this estimate. My advice is never to connect multiple PCs to the same UPS. The temptation is there, I know, but I would recommend that you implement one UPS for each PC system to get the full estimated battery time out of that UPS. A lot of PC techs like to connect other devices to the UPS to keep them up and running. That's okay as long as the devices don't draw too much power. For example, I know a lot of system techs that work with small businesses, myself included, that connect the organization's switch to the UPS so that networking remains enabled during the power event. That's always a good idea. In addition, they'll connect their internet connectivity equipment to the UPS, such as their DSL router or their cable modem. And again, that's not a bad idea. It keeps all your network connectivity up and running in a power event. And because the switch and the DSL modem or the cable modem don't really draw much power, it doesn't affect the estimated battery time very much. Now, there's an ongoing debate as to whether you should plug your monitor into your UPS as well. You can. In fact, I usually do. But just be aware that it cuts down the estimated battery time because monitors draw a lot of power. It's not as big a deal today with LED and LCD monitors, but if you use a plasma monitor or a CRT monitor, be warned that they draw a lot of electrical power. The one thing that you should never, ever connect to a protected power outlet on your UPS is a printer, especially a laser printer. That's because laser printers have heating elements that consume a huge amount of electricity and drain the UPS battery very quickly. That's it for this demonstration. In this demo, we talked about implementing a UPS. First, we talked about the role and function of a UPS. We talked about the process for connecting the UPS to the system. Then we went through the configuration process for the UPS, specifying which alarms to generate, how much time we're going to allow the system to run on battery, and the voltage levels that will cause the UPS to switch to battery power.